Hello, everybody. Welcome to day 6 of Intro to Coding Live. Today we're covering Python advanced data collections, and this kind of builds up off of everything we've been learning regarding loops and the other data structures, and it kind of just takes it a little bit further. Um, some of the stuff I know we touched a little bit. We saw multi-dimensional lists, but we really didn't kind of go too deep into them. Now we're going to kind of go over what that is and what that looks like in code. Um, and just other other more advanced uses of nesting the data structures into each other. So just as a quick review, remember how to access our elements of the list. We know how to define our list. We know how to access our elements and all of that. So one key thing, this you would just normally call it a list. It's one dimensional because there's one row here, but you tend to you just call it a list if you're not dealing with multi-dimensional stuff. And what I mean by multi-dimensional is this right here. A good a good way to terminalize it is calling them by like matrices and stuff. So this actually looks this looks three-dimensional. Um, so if we print this, now does everybody see what I mean by dimensional by the way that this is
It's got rows
constructed?
of columns.
Yes. Yes, it has multiple rows. And it makes it more readable. You can always just put it on one line, but it's a good habit to break your rows out especially when you're dealing with multi-dimensional arrays
Is
or
that just a
lists.
that's just a comma at the end of it to break it?
Yes, that's just a comma. Now,
Okay.
one thing about these is you can include a comma at the end of the last one and it won't cause any problems.
Gotcha.
Sometimes that's sometimes you can use that as a rule of thumb just in case maybe I want to go up and add another one and I don't want to if I need to add another row to this, I'm usually just thinking about the data I need to enter, and half the time I'm not thinking about check to make sure that comma's there. If I remove that comma, we're going to run into an error. Okay. So it's just a good habit with Python to leave a trailing comma here. Not all languages support that, but this kind of helps you kind of mitigate for the future and whatnot, just in case you need to modify or whatnot. Now, remember, so um you only need the comma if something file if you have another element. So not having a trailing comma on this list right here will not cause a problem, but if I remove this trailing comma,
It's gonna put the
now I
second
have a
row right.
problem. It doesn't put it together because this is bad syntax.
So it just throws an error that you're missing that comma.
Yeah, so this is talking about list
List.
indexes need be integers or slices, not a tuple. So it thinks that we're giving it a tuple here.
Uh,
No, no, it never actually prints the it's it doesn't actually print the comma. That's just the way the format. Oh, I didn't print that. That's just the way the formatting goes, the way this is. But the comma isn't actually included in any output. It's a separator. So it's for the code. The question was, um, if you don't put a comma at the end, will it print it? So with or without the comma,
It's
if I
still the
print the
same.
list, it will not have a comma at the end of here. The main key is it's kind of helpful for if I plan if I think I might modify the list in the future, or sometimes I'll just do it, not knowing whether I'm going to or not. You know what I mean? So now I don't remember if we covered this. Um, what do you think these print statements are going to output?
Um, Probably the it's gonna be the row. It's gonna put 147, I think.
147, that would be a column, right?
Yeah, I think that's what it's gonna be. Or it's gonna be yeah, I think it's gonna be 147, honestly.
You think so?
Yeah.
I've got Dominic saying 1, 2, 3, 4, 5, 6, and 7, 8, 9. And I've got Marcellus saying value in each position. Can you elaborate which position you mean,
Right.
Marcellus?
I was thinking that from each list, oh, excuse me. I was thinking that from each list, it would be, so for example,
One.
zero from the first one. Well, I guess
I think it's
we
gonna
have
be
to print three
159.
different times. Yeah, I think it's probably 1, 2, 3, 4, 5, 6, 7, 8, 9, probably.
Okay.
I think
I
it's
changed my
159.
answer.
Okay. So one thing, Dominic's first answer was correct because the reason why we have the commas here is this is element 0, right?
Yeah.
This is a list of lists. That's what makes it multidimensional. When you say it's multidimensional, two-dimensional, three-dimensional, etc., that's telling you you have multiple lists inside this list. So I'll clear this out and run it. To be able to get what you were looking for, Derek, we need a for loop to do that.
Okay. I mean, it makes sense after you explained it. I was just like
Understood. Yeah.
for because I saw the three print statements, and with them being bracketed, I was assuming it was taking out of each column, like the first index being one, and then five, and then nine. So that's what I thought was going to get printed.
Yeah, it is it is it does take a bit to wrap your head around it,
Yeah, but it makes sense.
but this we have to remember is index 0 of my matrix list. Okay. Because this is the first element of that. To be able to get, and that's what we're covering here. To be able to get to those values you were talking about, I would go like this. Because with the row, the column you were talking about was 147,
Yeah, I
right?
get you.
So now if I do that,
That makes
so
total sense.
because we have multiple lists here, we have to specify what from the second list we want.
That
And that's
makes
where it gets a little bit tricky, but this is a matrix kind of deal. This is
no,
like,
that makes total sense to me at least.
yeah. Any questions?
Yeah, so if you wanted to call from the second list of numbers, what would that look like as a print statement? What would need to be rearranged?
The second list, so the second element.
Yeah, second element, I'm sorry.
So we've done that here. If I comment these out, and I get rid of this index, now we have the second list. So now if we want
Okay.
the second element in the second list,
I got you.
we have to tell it which element we want. So now we get an individual
Gotcha.
number.
Gotcha.
There we go. Yeah.
That makes total sense. This is by far easier than what we were just pulling out the dictionary.
Well, so Dominic put in this statement right here, the print my matrix 1, -1. Now, okay, I see. Yeah, I see. So you're clarifying you want to reverse the first list. Yes, that'll work. So you can still put those methods in there. You could still do the slicing and all of the other stuff because it is a list. So you can do all of the elements all of the other methods and functions
What are
that
the
you would
two
know.
symbols?
What's up?
What are the two
The two
symbols?
colons?
Yeah, the two colons. What does that equate to as a symbol? Start,
That's
stop.
yes, that is. So this is start, stop, step. So
Okay.
by leaving the start and stop blank, that's telling Python that we want the whole list. And by adding the step -1, we're telling it that we want to step through it backwards.
Okay.
Okay.
That's what I got to get more like hands on with too is the symbols because I look some of the symbols they make sense, and then some of them I've like totally spaced it on.
No, I understand. Yeah. Any more questions on accessing the individual elements of a two-dimensional list?
Yeah, I think I'm getting it too. I like that. That was pretty enjoyable.
Okay. So naturally, just like with any list, we can reassign stuff because a list is mutable. So by this, we can change our single value right here. Fairly simple. If any questions on that? No.
So you put okay.
So you're used to being able to just call your element with a single bracket, but because we just want to replace one number, we've got to call which row and then which column we're
Yeah, makes
looking
sense.
for.
Makes
Yeah.
sense.
Because if we went and did this, we dump the whole list. See? We dump that whole list that was sitting in row 2.
Okay, yeah. That
Yeah.
makes sense.
So, as I said, yes, Dominic, the first one in a two-dimensional list, the first one is the row, and the second index is the column. There's that.
Yeah, that's what
Am I
I picked
reading it
up.
wrong? Am I reading your comment wrong or no? Okay, cool. So now we talked about to be able to iterate through all of them, we're going to need a for loop. But this is going to be a nested for loop because we're going through a nested list. So we go for row. in my matrix. And then now that gets us into our rows. Now we need to go for column in row, and then we print the item or the column.
Column and row, print column.
So the first one is just going over the rows, the first index. So it's going to be the first for loop goes through our first set of brackets. We need a second for loop to go through the second set of brackets if we want to pull the individual numbers. And that's what this looks like right here. Does that make sense?
Hold on. For row in my matrix. For column in row.
So
I mean, yeah, it does make sense just because I saw how it played out. But for for row in my matrix would mean go
that's
straight across. For column
so
in
what we're looking at here for our first run, when we go through the first time through this outer loop, what row becomes is my matrix's first index. Okay. So we're pointing row to this index, which is another list. So to be able to go through that list, we iterate again, just like we would with any normal, any singular uh, list, sorry. So I'm going to show you the difference if we just do a single. We just print the row. Do you see the difference here?
Yeah, it just gave you the same thing back.
Because we've only gone through the first index. So we're going, and the first index is another list.
Yeah.
So that's why if we're using multiple indexes, so if we had something that looked like, I'm just going to put brackets just to give you an idea. We'll just imagine each one of those refers to a legitimate list. We would need 4 for loops to dial into everything. So for each one of these, we need a for loop to go through it. Does that make sense?
Yeah, so you basically you would need a forced statement 4 times.
Yes, yes. And just like Dominic's saying, so we need a loop for each list in the matrix. That's exactly correct. Because the loop is only going to go through a single list. So if we start getting more complicated, we need to build a more complicated loop to be able to track down to what we're looking for.
I mean,
Okay.
it makes sense enough.
It's a little easier to visualize that because, you can quickly look at this two-dimensional list. It's like, okay, I need two for loops to get through this.
Yeah.
I do believe this style of question is on different types of programming exercises or programming challenges. So you will put your hands on this stuff in the future. There are efficiency things about this, but that's not within the scope of what we're talking about, so we're not even going to touch that. Now that we've done a two-dimensional list, we're going to look at a three-dimensional list. This is going to take me a bit to format out so it looks clean. So what we're going to do is Let me know if this is helpful for seeing how this is broken out while I'm doing this too. And I'm not going to lie, this can get confusing.
Oh yeah, I'm already tracking.
I'm going to try to see. I don't think I can. I might be able to try to put that on another line. So okay, so I'm going to comment these two lines out to make sure I didn't cause a syntax error. No, okay. So we can take and format. This is a three-dimensional list. So if there we go. How is that for readability? Is that more clear for people?
Yeah.
It is handy that VS Code is changing the colors of the brackets. But I think the key to understand here is we have the first list, which is the blue bracket. Then we have a sub list of that. So that's the second dimension, which we have three lists here. And then inside those lists, we have another set of three lists. So it's not going to look pretty if I just print it. Oh, yeah, I shouldn't have commented that. There we go. All right. It does get hard to read when you lose all the color formatting and stuff in the line by line. But remember, Python ignores the white space. It doesn't affect anything. So there's no problem. This right here this is usually preferred when you're trying to break out and demonstrate this stuff because I mean when you have all these brackets right next to each other and you're stopping and you're trying to count through that stuff, it can get a little bit tricky. So in this particular example, what they're looking to do is they want to append chicken to the row with 19, 20, and 21.
All right, explain to me how we got to that row. Because I get what they're trying to do with chicken, but I'm just not understanding. Like, okay, so the two in the brackets would be the
The two in the brackets
the third
is
group
this
of
list,
numbers. Yeah.
right? And
And
then
then
the zero
zero.
is this
Why is zero that?
because it's the first list in this list.
Okay. Okay.
Yeah, because remember, this starts again at 0, 0, 1, 2. So then if we run this
Where did it put chicken? Oh,
right here, append always adds to the end of the list.
okay. So append is basically that's what's directing it to be at the end of that list.
Yes.
Okay, I got it. I see what happened.
If we wanted to change one of the values or something like that, we would have to specify the index we wanted to change. So because we're appending,
It goes immediately to that end.
all we need is the list. We don't need to know what the item is inside the list because we don't really care about that. We're just adding chicken to it.
Okay.
But if we wanted to change one of the numbers in that list, so if we wanted to change the number 19, which is the first index 0, right?
It makes sense now. With chicken, then it's going to replace 19 with chicken.
Because now we actually need to know where this number is.
Yeah.
So then we add that third dimension call.
That makes total sense.
Okay. Clear as mud. All
Yeah.
right.
No, I mean that actually did make a lot of sense. I got
No,
that.
no, no. um, this can, I think, I think trying to track through for loops in this is where it gets goofy, depending on what you're trying to do. So understanding the basic concept, and that's where we're going here. Well, this is a very simple loop here, so let me
I
take
mean,
that
it's
back.
pretty
Yeah.
self-explanatory. Like in the my three dim, the last one that you did, you're calling for basically the third group of numbers. The zero in the next bracket would be the first group in that third list of numbers, and then zero would be 19 in that.
Yes. And
Yes.
in the
So
past, it's always been easy for me to conceptualize individually referencing these things, but I think, and it may have been given the context that I was doing. It usually wasn't just printing everything because that's usually not the only thing you're going to do with a multi-dimensional or a three-dimensional list. So if you start adding other logic in there and whatnot, you have to remember, you have to get back to remembering the basics. And sometimes that you can kind of lose a little bit of track of that if you're so focused on your quote unquote business logic of what we're actually doing inside this loop. That's what I
yeah.
kind of mean. Yeah. So if you're busy working out, let's say a few different if statements and all kinds of other little filter things, sometimes this simple concept can kind of evade you for a few minutes. You know what I mean?
So by the way that you just listed it with these four statements, because I get it's a three-dimensional four statement, but when you print item, what is I'm not understanding how it starts from 15.
It's because it's not starting at 15. It
Oh,
overloads
oh,
my
oh,
terminal.
oh, okay,
Yeah.
okay, makes sense.
Yeah.
Because item would be basically calling for the whole list. You're just putting it in a column.
Yep. And we can add little debug pieces. And when I do confuse my logic, this is exactly what I do.
Just print each one out.
Print each one out. And this will get messy,
But
but
it shows the logic behind it.
yep, it shows what you're going through. And then a lot of time that's the aha moment of, okay, that's right. That's what I'm doing right now. And
I
then
mean, that isn't really
yeah,
messy per se, because like I like it. What it's doing is totally explaining like what you're trying to do. So
yeah.
that's pretty cool.
So yeah, you can trace down your loops that way. That's always a great way to figure out. Yeah, I know we were talking about that, a print statement to print out whatever that variable is so we can see what it's doing is a great way to understand more about how your loop is going through things. So maybe even the hard to read dictionary loop, maybe even just printing that out so you can see what's going on might be helpful for you. That's another place where you could go through, play with it, throw print statements in, and just see what's going on.
I got you.
All right. So we went over the append. Here they're appending another list. Does that make sense?
Yeah, because it's bracketed.
Well, they're not accessing any of the elements. So
Well,
what
no,
they're
because I'm
doing,
saying because they're adding that append statement, and then it's in parentheses bracketed, and that would be adding your new list because it's
yes.
bracketed. That
And
makes
what
sense.
that does is it adds another list as element number 3 or element index 3. So what we are effectively doing is making the list bigger. We don't need an index because we're adding it to the whole list. All right.
Yeah, because my matrix is still the variable that hasn't been changed.
Hmm.
Okay,
Well,
mate.
my matrix still refers to the outer list.
Yeah.
So when we append to the outer list, we're inserting right here. So that's the same thing as if I just went and did this.
Yeah.
Yeah.
Because like you said before, the append is always going to put it at the end of that list unless you call for something else.
Yeah. So the location in this example, Dominic, is the entire matrix. We're adding another list, so we're making the outer matrix bigger. If we want to,
If you
if
want to
we
specify the location, you would have to use the brackets again and then
if
call for those locations.
if I wanted to
Yeah.
add to this list, I would have to specify that,
Which puts
and
it after it. Yeah.
which
Okay.
adds another list into it. It makes it all kinds of crazy, but
That's pretty simple. That's not too complicated.
okay. Any questions on that? And Dominic, was that the location you were talking about, or that last example was that where you were referring to, or did you have something else in mind? All right. Um, so we can replace, just like we can append, we can completely replace the row. I believe this makes sense, correct?
Yeah, it's starting from the back of the list.
And what we're doing is we're just replacing the last list. With 10, 11, 12. So we take the 400, we're taking the list with 400 in it and just completely swapping it out.
Okay, yeah.
Let's see here.
So why question. With the second one, with my matrix -1 equals bracket 10, 11, 12, why couldn't you put another append statement in there? I
Because,
mean, I guess you could, but you're over typing. You would still have to call for the
well,
-1.
appending is adding. Okay. What we're trying to do in this example is replace.
Oh, okay. So that
Yeah.
takes that away and then inserts that.
Yeah. So what we're
Okay.
doing is we're completely swapping out what list sits there. Now, let's see this. Okay, this one right here is doing a little bit more to the matrix. So let's break this down. Now, I believe we did talk a little bit about using range and length to be able to get the size of our um, list, or just about any variable minus a bool, I think it was, right? So again, we're running 2 for loops in my matrix. And this one is trying to actually replace individual numbers. Okay, so let me clear this out. We'll run it so we can see what the results are. So this is where I was talking about starting to add logic. Inside the for loop, we've added a condition to just see if we're at the second element or index number 1, and that's the only one we want to change here. Everybody see that?
Mm,
So that's why you have 200 here, 500 here, and 800 here. I'm trying not to cover up the list from the top so you can still kind of see The other values we didn't touch. Does that make sense?
No, not as to how we got to those bottom three lists. I
Okay.
understand everything else, but just not how we got those bottom three lists instead of. Oh, wait. Um, yeah, just go ahead and dumb it down for me a little bit.
So now when we replace it with the row and column that we used from before, the only little tricky piece is when we're running into this item, right? So,
Yeah.
because we know where our row and column is. That's our row, that's our column. So the item is the value done this way with the enumerate function. The item is the value that sits at that index. This is how we kind of unpack those so that we can. You could have easily done. You could have done my matrix column times 100. That means the same thing in this particular example. Do you see that? We're just shortening it by giving that variable the name item and referring it to as item
Okay.
instead of the longer syntax here. Both of them do the same thing. It's just one can be easier to read.
I got you.
Okay. And how we're getting to the second element is that's the specific column we're looking for. Now, I see Dominic is asking in real life situation, what do I use? This is more universal. It's harder to read, but it's more universal. The enumerate function belongs to Python. So that's one of
I mean,
these things.
enumerate it means again.
Um, yeah, this for Python is shorter and more to the point. Um, didn't we look at that up yesterday? Wasn't enumerate goes, yeah,
Yeah,
it's to
count.
count. Yeah, yeah.
Okay.
So yeah, because we're getting our indexes from the first row. So we need to know how many indexes are inside of there. If the other way to do it, if you were going about it this way, you would have another range len function in there. Okay. So this particular example shows you using one function, the using the column from this piece right here, you would be using two functions, range and len.
Yeah.
So it can get more confusing to read.
That's
And
still.
again, like I said, variable names are important to be able to help remember where you're at. Any questions there?
I mean, it's still a little confusing, but I got the main idea on it.
Yeah, this one's one where we can actually go through and print.
I had a question.
Yeah,
So
go ahead.
because I see where it says if index is equal to one, how exactly does Python know to look at the I guess the one from I'm trying to see the best way to say it, the one from each list, like the two, the five, and the eight.
The 2, the 5, and 8, because that's position, that is index 1, 0, 1, 2. So 2, when it comes in here, let me run through this. I'm going to run through this and this will break it all down. So when we first run through the row, we're at row 0, and then we
Yep.
enter in the loop, which we're at column 0, and our item is 1.
Yep.
Okay. But the column we're looking for in the if statement is 1. So we skip over this logic and we jump back up to the next we run the for loop again, and now our index is 1. So if I go like this, when I run this, you see it triggers it as soon as our column is 1, we're going to execute the logic inside.
Gotcha. And I guess let me reword my question. So,
Okay.
what in that block of code is telling it to actually look at index 1? Like what
That's
is it
what the
keying off
call
of?
is. So
Okay.
enumerate is doing that. Okay. So when enumerate is broken, when we use enumerate, we can unpack it into these two variables. The column is the index, and the item is whatever that value is. So if I change this to value, okay, because that's our current value for this particular iteration of the for loop. Column or index are interchangeable here. So if it doesn't matter what my variable is named, but if we're dealing with a multi-dimensional array, it's my preference to call, when I'm dealing with multi-dimensional or two-dimensional anyway, I like to call this second loop a column, because I'm referencing whatever my value was from the first loop as row, and it kind of breaks it down in my head as like an Excel sheet. Okay, so you know how that's all mapped out in rows and columns, and that's how I go about figuring out this sort of problem. So the column is your index, but that's your index of whatever row we're on. So like that's why, so our row being the 0 row, the first row, and as soon as our column reaches the number we're looking for, the first index or index 1 or the second element of that list, then we do something to it. Is that helping, or am I confusing it more?
No, that helps a lot.
Okay. And sometimes, again, yeah, to try to help break it out, adding these print statements in to see how it's breaking things down and everything kind of lets you see what's going on underneath the hood. Dominic, I see you say two things can be true, confused help. Could you elaborate on that? Oh, I understand. Yes, this is kind of, it can be a bit confusing, but a little more helpful. This is another one that's really handy to put your fingers in there, and um you could try playing with the values or something to see what's going on, and just to see exactly how to get what element you're looking for. So like if we decided we wanted to change this to the third, if we put this as a 3, will this if statement ever run?
Um, I don't think so.
Do you know why?
Because it doesn't get to that part in the loop.
Yeah, just like Dominic was saying, there is no index 3. So we would never execute this, but it would not break anything. It would still just run through completely fine. We would just not change any values.
Yeah, makes sense.
But if we swap this to index 0,
It's gonna continuously run.
no, We're still just getting the first column.
Oh yeah. All
Yeah.
right.
So I don't believe there's a way. There may be, but I think it's pretty difficult to make a for loop run infinitely. That's more of a concern about while loops. Okay, so for loops, you use for loops when you know there's a definite end, when you have a limited amount, like a list. There's only so many items in a list. So you can easily iterate through the list and not run into any problems as far as like an element not being there if you just stick to the functions that rely on the real data there.
I got you.
All right. Any other questions? Oh, let's see here. This is just another interesting thing to do with, we don't need this print statement. This right here. So we're using modulus 100. You remember what modulus does?
Not a clue.
Modulus gets the remainder division. So it takes what I is. What we'll do is we're going to change I to num. So this is our current number. And because all we've specified was in one number inside range, 1001, we start at 0 and we run all the way through. And basically, for modulus, we're taking our num and dividing it by 100 and checking the remainder. We don't care about any other part but the remainder. But if it evenly divides, then we have a number divisible by 100. You see how
Okay.
that works?
Yeah, but where I'm confused at, why is what is the percent symbol?
That is the modulus symbol. That's the modulus operator. We covered that early on, but we haven't really touched it a lot.
Okay.
So we did play with it a little bit. Getting even numbers. So if we divide by 2 and get no remainder, we know that's an even number, correct?
Yeah.
And that's just, all we're doing is just using modulus to get something that's divisible by 100 instead of 2. That's all this really is. And remember, the range is exclusive. So if we want to include 10, we have to add 1.
Yeah. Okay.
Okay. Oh, thank you, AJ. It is break time, so you guys, I'll give you 10 minutes and we'll pick right back up where we left off here. Okay, so we went through, we covered the modulus, covered a little bit more complicated lists and everything. Now, we can also go through and nest lists inside dictionaries. So what we're going to do is copy this and we'll make sure we put our print statements in here. I'm going to clear this, run this, and then talk about it. Okay, so what we'll do, so you can see the before and after here. Okay, so now what we're doing here is we initially establish our dictionary with the key hello. We're used to this, right? No questions there? Okay. And then we go through and we change our hello key to include a list. And we can see that right here. So the value goes from being a string to a list of strings. So in order to access that, we first pull our key, which gives us our list. And then we have to request the index if we want a specific element from that list. Does that make sense to everybody? All right. Tons and tons of thumbs up. Good. So naturally, we know that it can't stay that easy, right? So this is a more practical example where we start actually building out a dictionary to hold data, to hold a person's data. And we can see that this is quite a bit. This is a quite large dictionary. I know I mentioned before when we kind of were covering dictionaries initially that in this instance, like having a class key, we could put a list of classes inside here. And on the same token, you see they have a key children, and it's a list of person names, a list of strings inside here. Does that make sense to everybody? Well, the rest of the dictionary should look pretty familiar. And now we can have a look here, and we will add this loop and go over what that's doing. I'm going to rename the key and the value to help with being able to read this a little bit. And that's a feature of a lot of IDEs. Instead of just going in and finding and replacing and stuff, the nice thing about using an IDE or a code editor is with VS Code, you have this rename symbol. And when I change the one value, you can see that it changes everything that's related to that value. So if we had like the word monkey and that has the subtext key inside it, if we used find replace, it would have replaced that part too and messed up whatever was going on there. So this is very handy on trying to rename things to be able to make sure you get all of the right variables. And in this case right here, if I had, I'm going to rename this back to K. I'm going to show you another. I do not know what you're doing here. Now this K is outside of this loop. So if I rename this K to key, well, that was unexpected. It shouldn't have changed it outside of the loop. This key only exists inside this loop. Remember, we were talking about scope. So if I tried to print key outside of this loop, it'll give me a variable undeclared. Does that make sense? This goes back to the scope concept that we were talking about earlier. So I don't believe it should have renamed that. Yeah, it should not have renamed that to key. I believe inside the desktop version, maybe it doesn't, or maybe it's just something you have to pay attention to. All right, so we're going to print names here. Just keep that in mind with the zyBooks. A lot of times there should be a print statement right here just to be able to see what the output is. So we're going to run this. Let's clear out. So what we're doing, we're checking if the person has children, and then we're adding and okay, and we're assigning them to parent name. And then what we're doing is we're grabbing the children and pulling their names. It's a little bit tricky, but if you notice that the way that, and this comes down to the way they structured the dictionary. The person names will line up. I know that line moved. These person names will line up with the person keys. And that's how they've structured this. So this looks like it has kind of like a relationship. Does that make sense? Where they actually establish the relationship is in this code. So outside of this code, there is no actual relationship, but they're using those keys to be able to construct the new list of parents. Everybody see that?
Vaguely.
It does take going through. We can start. Do you want to see the process? You want me to add some print statements in here and break out the loop a little bit, or what do you want to see?
No, so I'm pretty good with like the for and the if statements or the elif statements. Where I start getting thrown off here is because I see that we change the value to parent's name, right?
Yes,
Or,
we create this variable. We're creating this variable, parent name,
yeah,
and we do that only if
there's greater
there's
children than zero.
if there's greater than 0 children. And how it's doing that is it's getting the length of children. And we know we can get a length of an array.
Mm-hmm.
And if it's empty, it'll just give us a 0.
Mm-hmm.
So it's a quick and easy way to be able to pull out who's a parent
So
in this
then
particular dictionary.
it calls for the first name of the parent from the school dictionary key, and then also with their last name.
Yep, which those are 2 keys inside the dictionary.
And then can you just scroll back down a little bit?
Sure. I'm gonna make the terminal smaller
That's
and see if that helps so that you can see one of the dictionary entries and the logic that it's going through.
So then it gets to the third statement for child in school dictionary, key children's names, parents. Okay, so it's listing the children's parents and the children's information by
Yeah.
first and last name. And then the else just continue. So does the else statement here make it continuously run to find those?
It just means that if children is 0 or less than 0, it hits the else, the continue just loops through.
That's okay.
This block can be commented out and it would still work.
So my question would be, why would you want it to run through continuous if the first time, like, what's the scenario behind this? Like, are we adding to this list? Like,
What do you mean? Okay, so what do you mean continuous?
So
The
when
continue statement?
yeah, so like if you're telling it to continue to look through the dictionary for if it doesn't
So
find children.
I'm going to reverse this statement and I'll show you what it's doing there. I think it's the keyword that's getting you.
Okay.
So we'll go if it's greater than or equal to 0, continue. Else. Now this will give me the same result. Okay. Continue doesn't make it run continuously. It means stop processing, go to the next element in the loop. Does that make sense?
Yeah,
Remember, that was continue and break. If we put break in, we stop the loop altogether. Continue skips to the next step. No more processing. Let's just skip to the next step.
okay. I guess maybe I'm not
See,
understanding what happens after continue because I get it. We'll go back through to start looking for the same information. Or when you're saying skip to the next element, what would the next element be? I guess.
so if we start at element 0 and we hit this continue, we go to element 1. Okay. So element 0 is person 1, 2, 3, 4, 5. If we hit the continue block, we should hit the continue block because, or no, we should process because they have kids. But when we hit, this is the next element, we
Oh,
have
okay.
no children, so we
I
should,
see what's happening.
there's
Okay.
nothing to process, so we jump right through it. So what I
Okay.
also did is that else statement is actually not necessary. Okay. The reason why is because we have the continue block, and you see how it comes up with the same information. This stuff does not need to be in an else block because we already bailed out at the condition that we're looking for. If you have no
Isn't meant to
kids,
continue to the next element.
yeah, yeah. This actually probably both of them
That's
process.
way simpler.
Yeah, this might be easier to understand because okay, uh, if I have 0 children, then I'm not doing anything.
What would
Otherwise,
be
I'm doing all this
if
stuff.
you were like putting this statement out for a program, would you go with the first example or the second example?
I'd probably go with this. Find all my cases to bail out of processing first. So this is where you're filtering out your information. You're filtering out, whatever your criteria is.
Yeah, I
Building
like
if
that.
statements works both ways. You remember how I was talking about the other instance where I assumed failure and I only modified the state on a true case. I didn't have to change it anymore because it was already false when we came in, right?
Yeah,
Yeah, this is similar to that kind of concept. And
I
this
like
comes
this
down to
first
personal
example so
style.
much better.
The first example, uh,
Yeah, from
which
line
one?
90 to 91.
This one right here, then? The one that's in the example here?
No, so in the practice PY, I'm sorry, from line 90 to 91.
Okay, so you like what I changed it to. So if I get rid of
Yeah,
all the
because
rest
the
of the
other
stuff, yeah.
stuff it's just so hard for me to wrap my head around to get the same process that it does for
Hmm.
that first one.
And I believe this right here, this can be more approachable for people that are focused on how the if else statements work or anything. And
Gotcha.
sometimes you can kind of sometimes people can trip themselves up when they try to look for that. Oh, this is value, right? Oh, no, that was V. That's right. Sometimes they can trip themselves up using this filter out mentality. You know what I mean? Go through
Yeah,
everything that I'm going to filter out first and then process what's left. That's kind of the approach that reformatting or refactoring this way does for me.
I
And
got you.
that that comes down to how you problem solve it in your head. And when
Yeah.
you map it all out, what makes sense to you is going to be the way that you're going to try to code it. And
I
that's
guess if it wasn't giving me what I was asking with the for and if statement and then continue, then I would probably go down to lines 94 through 99 and start that process just to get a better look at like what's actually coming out from it.
yeah, yeah. This tells me that when I'm manually looking through these things, if I've got 0 or less children, which actually you can't have a negative value for length, so I can easily just do that. This actually makes more sense if my length is 0. So that's
100%.
yeah. So when I'm looking through these things, if my children is 0, I'm not looking at those records, but this is one of the records I should be able to find in here. So Jorge Gonzalez. Did you said the one for Gertrude Brown is wrong, Dominic?
Right below. Go down. Her class is people.
Yeah, her class is people. It's populated wrong, but we could easily fix that. And this is what happens when
So what happened?
fat fingering, copy and paste.
Oh, okay.
Did it break? Yes, it did. What is the problem here? Because the person doesn't exist. That's why it broke.
Yeah, because it was originally assigned to children.
Yep. And how we get that is you see this error right here? It's a key error. Usually that means that key does not exist. And that's why. For us to make that work, that is probably, so this is not a fat finger thing. This is probably just an oversight thing, and we could solve it this way. Cross our fingers and nope, there's another one that doesn't exist. So if we break that out of there. No, it doesn't like that one either. But now we have the children. You know what? I bet you see class is kind of misleading here because we don't know if it's a subject or if it's people in their class. We don't know what the context is. So they might have meant that for that class, but to be able to, but when we move this over here, we get Gertrude Brown in our list of parents, right? It does look wrong, but it's tough to tell because no other example has any other information in class.
That's where it would have been helpful for like a comment to comment out class.
Right. This is where if this was sitting inside somebody's program and whatnot, you want to see an example of what good data looks like.
Yeah.
Because we don't know like if that's people in your class, if that's classes you are taking, if that's classes you are teaching. Oh, wait. So
I think
is
it was right the
teacher
first
right
time.
there? Is teacher is true. Yes. So given
I think
that,
that's how it's supposed to be because if you look at it, the last name Brown, that's the only time it pops up, and then all the other children share the name with their parent, aside
mhm.
from Kelly Smith. That that one doesn't make sense either.
Yeah, the other piece that I wasn't looking at is teachers true? And I believe none of the rest of them have true for is teacher, right?
I think that is accurate. I'm scrolling through right
Yep,
now. Yeah, is
yep,
student, is teacher. Yeah.
yeah. So this gives you the idea that another filter that you could run is looking for all the teacher students. But we know that
That
that some of these people don't exist, so it would get broken at that point because these
so
keys just don't exist. Go ahead.
so off this list you could print um who the teachers are.
Yes, because that's you just check for the bool whether teacher was true or not. And if the three IDs that we deleted out to make it work under children existed, we could get a list of students. And pretty much the same way that we were getting the list of kids or children.
So would you, if you wanted to print the teachers, would it'd be an if else statement. It wouldn't need a for loop, right?
You need the for loop to go
Oh, to
to
go through
the
each one.
dictionary. Yes.
So you would change it if length value of
So if
teach.
no, it's actually a lot easier than that. So if
Okay.
all I'd need to do is if
Oh, because it's a Boolean,
value,
you don't, yeah, if
right, if
value,
key equals is teacher. Oh, come on. And value equals true. I think, did I do that and wrong? There we go. Spelling. I have to capture it. I have to capture the name earlier. So if I go like, oh, see, yeah, this one's a little bit trickier, pulling their actual. So what I'm going to do is I'm just going to just go this route. Just for simplicity's sake. So we're iterating through and did I? Oh, no, 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 no. This still requires 2 for loops. All right. The thing that this is a dictionary with a dictionary. This is a dictionary of dictionaries. That's what I failed to explain. Okay, you see this outside bracket right here? And then we have another dictionary. This is one dictionary. Okay. So what we would do is we'll go about this a different way. We'll go and then this is where we run the if loop or the if. So if mk equals I don't think we need that. No. We go if yeah, MK was going to be my key, but now I'm thinking about it, we don't need to do that. So if we go MK now, value is teacher equals true, and this is a string. I believe that should work right there. And we don't need to print names. All right, do you see that? So the part that I was missing the first time is, and it does get difficult because this dictionary spans what, 80 lines, right? And yes, this is a nested dictionary. So the person is a key, but it's also a dictionary. So when I refer to this value right here, it is a dictionary. So I access it just like a dictionary, so we can pull the is teacher key, check that, and pull their name from the dictionary. Does that make sense? Any questions?
I'm good on that, but now I'm curious because you kept putting MK and MV. Does
I was thinking I needed to loop through the keys. I was overcomplicating it. I didn't need to have the secondary loop in this particular situation. In the other situation, we need the nested loop because you're looping through to get more information.
my question's a little bit simpler than that. Does Python, if you put MK because you defined key and value, if you put NK and MV, does Python know that's what you're talking about?
It doesn't mean it. What it is I was working on creating a new for loop so that at the end of the day, they're still just variables,
Hmm.
MK, MV in this particular instance. If we're just going to say that this is a different dictionary of dictionaries for something. Like maybe it's a course list and our classes actually refer to IDs in our course list for just a theoretical stake. I have this MK and MV, which are specific in scope to this. But because this for loop is in this scope, I also have access to key and value. So I can pull the parent dictionary that I found here and pull a relationship, kind of build out a string relationship or something, if that makes sense. Like if our classes here were class IDs instead of person name, but this dictionary is just focused on the people. And let's say we have a class dictionary where we have like CS 101 and that sort of, the way your college courses are broken out. And you wanted to display more data and just not the class ID. So you pull like the class name, how many students and all that stuff from a different dictionary. That's where this would come in. Okay. Because
But
you'd
right,
be taking in this, it doesn't apply in this case because we don't have a second dictionary of dictionaries.
yeah, but right
Yeah.
now MK and MV are undefined variables, correct?
Well, outside of this, they're undefined, but inside of this loop, I just defined them.
Yeah.
Yeah.
But if
So,
you weren't doing it in the school dictionary items, if you were doing it in the string prior like you were trying to, it didn't have there was no definition for it. So it wouldn't have pulled anything, correct?
well, yeah, you see, it it would have pulled what it would have done is it would have pulled each one of these as tuples. Okay. And then the
Oh,
key would have
okay.
been first name and going through it that overcomplicates it because I don't need that. I don't need to iterate through. I just need to check one key and then pull their name out. So
O-
that was me overcomplicating it, is what it was.
Okay.
Okay.
Does that happen a lot with software engineers overcomplicating things?
It depends. It depends, and thinking out through the problem and that sort of thing. I didn't go through and kind of like write it down and kind of map out my thinking. This is a disadvantage of trying to just start throwing code at the editor without like fully thinking through what you're trying to do. You know what I mean? Because
Yeah.
what I was trying to do was simplified by two lines. We didn't need another loop, but that was just for that specific use case. With this, we do need the other loop because we're going through, excuse me, an array. So this is not looping through a dictionary, it's looping through an array. And that's where I wasn't really fully thinking it through. I was trying to look for another way to use a nested loop, but my particular use case wasn't valid. So the only way in this example to use the nested loop, other than iterating through the class, but like we saw, three of these people don't exist, so we can't pull that other information if you want to pull their names or stuff. So you could list the people, but that's not as aesthetically pleasing or anything, if that makes sense. All right, so we could go ahead and take a 10-minute break, and I believe we can come back for well, actually, yeah, I mean, we're at the state where we've got one example here. We've got still one more piece from the demonstration. This is looping through a triple loop. Does anybody want to take a break, or you want to continue through this? All right. I've got one answer for push it. So effectively, we're looking at a another three-dimensional loop here, or three-dimensional array or list, and I believe we've seen this example before. So, any questions on this? I can add the print statements in if you want to see the logic. Thumbs up if we're good. All right. So if there's no other questions on any of the material we covered, I can go ahead and let you guys go. Okay. Okay, I see. Looks like we have no more questions. So that's all we have for today. And I'll see you guys on Monday, where we're going to start working into kind of a project exercise style of day. All right.
Have a good night,
Well,
DJ.
you too. Thank you.